Okay, so after that, after proving these two sides are equal and these two angles are equal, then our next aim is we have to prove this triangle as a right triangle. Okay, so let's see this. Yes, okay, you can ask. Just wait. Which one? This one? No, this is not isosceles. Okay, yes. So isosceles, no problem. But right triangle is also isosceles. Okay, in which the condition is that angle must be 90 degree. So isosceles triangle may be also 90 degree. No problem. Okay. Only thing is that we have to prove this is as a right triangle. Okay. So what we are going to do now? Let's see in this triangle. In triangle ABC, angle A plus angle ACB, ACB plus angle ABC. ABC must be equals to 180 degree, right? This is 90, so we can say angle ACB plus angle ABC is equals to 180 minus 90. Okay, and we know that this one we have written this ACB. This one is equals to this PBQ. So in place of this ACB, we can write angle PBQ plus this is ABC. ABC. This must be equals to 90 degree. Okay. So let's see. This is the second condition. Fine. Now we know that this is a straight line. And here this angle is there and this angle is there and this is one angle. So the sum of all the angles on a straight line must be equals to 180 degree. Okay, this I told you the linear pair axiom. Linear pair axiom is that on a straight line the sum of all the angles must be equals to 180 degree. So by that concept we can find this angle must be equals to 90 degree, right? So we can write here angle ABC plus angle this is we can take CBQ, angle CBQ plus angle this we have taken PBQ. So PBQ must be equals to 180 degree. The reason is that angle is forming on a straight line. Okay, so the sum of these two angles is 90 degree, PBQ and ABC. So PBQ and ABC is 90. So we can find this angle. Angle CBQ must be equals to 180 minus 90. So angle CBQ is equals to 90 degree, right? So this is the thing that we have proved this triangle as a right triangle. Therefore we can write triangle BCQ is a right triangle. Okay, understood? Okay, now see the next step. Have you written this? Okay, have you written? Okay, so we have proved this. All triangles are right triangles. Okay, now we know that this is APQC is a trapezium. So the area of trapezium must be equals to the area of the sums of these three triangles. So by using that equality, we can find this theorem. Okay, so we can write that since APQC is a trapezium. Fine. So the area of trapezium must be equals to area of triangle ABC plus area of triangle BQC plus area of triangle BPQ. Area of triangle BPQ. Okay, so the area of this trapezium must be equals to the sum of the areas of these three triangles. Just only we have to put the formulas of these areas and we will equate this equation, and then we will find this theorem. So area of trapezium, what is the formula of area of trapezium? It is half into sum of parallel sides into height. So this is half into, we can write sum of parallel sides into height equals to area of right triangle is half into base into height. Half into base into height. We can write like base into height. Plus this also half into base into height. Similarly, half into base into height. Okay. Okay, so this is half and the sum of parallel sides. So what are the parallel sides? These are the parallel sides of this trapezium. This is equals to A and this is equals to B. So we can write A plus B and into H. H is this height. This is A plus B. Okay. So this is also A plus B. Equals to, this is half. We are taking common half from all these formulas, right? Then we have to write base into height. For first triangle, base is B and the height is A. So it is AB plus, for this base is A and B. This is AB. Okay, and then plus for this triangle, base is C and this is also C. So we can write C square. Okay, so these half will be cancelled out. Now we will solve this. A plus B will be A square plus B square plus 2AB. And here AB is 2AB, then plus C square. So these 2AB will be cancelled out. Then we will get A square plus B square must be equals to C square. That is the proof of this theorem. So in this triangle we have proved A square plus B square must be equals to C square, right? So this is the proof of this theorem. Hence proved. We can write this as proved. Okay, so write this. Any confusion you can ask. Okay, so just I am recalling all that again. What we have actually done, we have given this triangle ABC. This is a right triangle. Okay, and we know that in right triangle the square of the hypotenuse equals to this sum of the squares of the base and the perpendiculars, right? So we are proving this. So what the first step we have done, we are extending this side, and the condition is that the side that we are getting after extension must be equals to this perpendicular. So this is A, it means this is also A. And the second step, we are drawing the perpendicular from this point. Condition is that the height that we are taking must be equals to this base. Only we think that the triangle is standing like this, and we are just making the triangle like this, rotating like this only. Okay, and we have joined this and this also. So we are getting this shape of trapezium having three right triangles. So we don't know this is a right triangle, so we have proved this. Okay, so how we have proved? We have to prove this angle equals to 90 degree. So first we know that these two triangles are congruent because both are right triangles, so they are congruent. So by that we have taken this angle equals to this angle. Okay, and then from this some property of this triangle we write this angle plus this angle plus this equals to 180 degree, and we already proved this must be equals to this. So in place of this we are writing this angle. Okay, so we are getting this plus this equals to 180 minus 90 because this is 90. So we are getting this plus this is 90, then definitely this will be 90 degrees. So by that we have proved this is a right triangle, and now we are putting the formulas of the areas because the main figure is the trapezium and that is divided into three right triangles. So the area of the trapezium must be equals to the area of these three right triangles sum. So by just putting these values according to the figure, so we are getting this final theorem. A square plus B square must be equals to C square, right? Okay, so for a triangle that must be a right, the condition is that the hypotenuse square. Hypotenuse is basically the largest side. So the square of the largest side must be equals to the sum of the squares of the other two sides. So if suppose we don't know that this triangle is a right or not, and three sides we are having, so we have to ask that is it a right triangle or not. So what we are going to do, take the largest side, square it, and other two sides squares and sum that. So if we are getting LHS equals to RHS, then it must be a right triangle. So come to the exercise. First do some questions. Question number 1, exercise 12. One more method that I was discussing related to the similar triangle, that you can watch on your app. I have uploaded that. Okay. Still any confusion you may ask. So question number 1, length of sides of triangles are given below. Determine which of them are right triangles. In case of a right triangle, write the length of its hypotenuse. So first part is 386. Question number 1, exercise 12. Only one exercise is there in this chapter. Question number 1, part first. The sides of a triangle are given 386. This is 3, 8 and 6. These are in centimeters. Okay, so we have to check that is it right or not. So what is the largest side here? That is 8. So we will see that 8 square must be follow this 3 square plus 6 square for right triangle. So this is 64 and this is 9 plus 36. So it will be 45. Okay, so this is not equal to this. It means this triangle is not right triangle. Okay, because it's not following the PGT. So like this you can do any other part also, second and third part. Okay, you can do this, very simple. Now move to question number 2.